Hello and welcome to this recording of a VSL webinar that was held on November 9th, 2022 about the new liquid flow meter calibration facilities at the European Centre for Flow Measurement. The recording will talk about a few things that were of course discussed during the webinar. That is of course not longer possible. So if you have questions, you can always send them to either myself, Erik Smits, or my colleague, Jacoline Boonman, and the email addresses will be in the last slide. Thank you, and I hope you enjoy this presentation. During this webinar, I will talk about a few things, and that's basically the status as the facility is at this moment in time, which is 9th of November 2022. So first, why a new location for liquid flow and volume metrology? New liquid flow meter calibration facilities at the European Centre for Flow Measurement. And I'll talk a little bit about the vision behind the new liquid flow calibration facilities. A few design considerations for the liquid flow calibration facilities. Then I will go into the most important part, I think, for today, the realization of the liquid flow calibration facilities, the measurement traceability, the measurement capabilities, and what can VSL do for you with these new facilities. I then explain what the complete European Centre for Flow Measurement looks like today. And then I'd like to invite you to the European Flow Measurement workshop that will be held next year. And then there will be some room for questioning. Before we continue, I'd like to introduce VSL, the National Metrology Institute of the Netherlands. Don't be mistaken, VSL is the only National Metrology Institute of the Netherlands. VSL maintains the national primary measurement standards of the Netherlands, a task we do for the government. We are a private company with a public task. We have approximately 100 employees, from which 50 are university schooled. We're independent, reliable, objective, and impartial. We are market driven and work internationally. Our service to you contains, for example, calibrations and validations. We do that mostly in the laboratory, in some cases also on site. We are a reference material provider where we do innovation, so research and development, consultancy, metering review, and we do VSL CMC certification of your test facilities. We have a metrology college where we give training and courses. Our phrase is measurement beyond all doubt. Why do we need a new location for the liquid flow and volume metrology laboratories? The current water flow and liquid volume facilities are located in Dordrecht, and that location no longer meets today's requirements for a flow meter calibration facility. And you can see that in the pictures. It's very narrow, it's very little space to work on customer and research projects. Expansion of the flow capability is not possible. There's no space. Facilities are fitted in to match the building instead of fitting the building to the facility. And it's actually in the middle of the city of Dordrecht that would like to make houses on that location. And there are many other things why. Then the LNG flow and composition facility, which is located at the moment already at the Maasvlakte, it needed a relocation of the facility for a major energy transition project in the Netherlands called Porthos. The project is for the transport and storage of CO2 in old gas fields in the North Sea. The location at the Azieweg was not ideal for travel due to the distance to residential areas. That means it was very far to drive to, and people that have visited know this. More information on the Porthos project you can find in the link that I provide here for you on the bottom of this slide. From this moment forward, I will talk about the new liquid flow meter calibration facilities. Therefore, I will not talk about the LNG calibration facilities. There are other videos online that you can see for that. So I'll talk about the water flow WS650 and water flow 2500, as you call it WF2500. So why does VSL need new liquid flow calibration facilities? Therefore, I need to talk to you a little bit about VSL's vision. VSL needs a future-proof location to meet the national measurement standards. We need to provide facilities in flow measurement that are ready for the energy transition and beyond that period. And of course, that also includes the LNG facility that I am not talking about in this presentation. We need to provide a larger flow capability for SI traceable calibrations for customers. We need to fulfill the requirements and requests of valued customers. We need a location where customers can meet the experts of the VSL team and learn about flow measurement. We need a location where you, the customer, can witness the calibration of your instruments and where you feel safe and enjoy the time spent. Before I show the realization of the facility, I first need to take you to the design considerations that we had at the start of the project for the liquid flow calibration facilities, so you understand what we are constructing today. We are constructing two new water flow calibration facilities. The first one is an upgrade of the water flow facility coming from the city of Dordrecht, which we call the WS650 facility. That facility runs at 400 cubic meter per hour or tons per hour. And from this moment forward, I will only name cubic meter per hour, but know that tons per hour is the same in water flow measurement. That facility that we are now going to build will be upgraded to 650, and it will take over all the weighing scales, etc., from the current facility in Dordrecht. But it will have a new Coriolis master meter section for the larger flow rates, because for the smaller flow rates we already had Coriolis meters in the city of Dordrecht. The very important part that we are going to do is we're going to reduce the connecting volumes, and that means that we have less uncertainty to account for when going for smaller flow rates. And the second facility that we will build is a brand new facility for flow rates up to 2500 cubic meter per hour. So we will call the WF2500 facility. The master meter method will be utilized there with Coriolis mass flow meters. We will connect the 2500 system to the 650 system to calibrate the 6 Coriolis mass flow meters that are in that facility. But we cannot reach the 2500 cubic meter per hour, so we need to bootstrap the 4 largest Coriolis meters with each other to go for flows up to above 1300 tons per hour. The facilities have a combined storage bunker of approximately 350 to 400 cubic meters, creating natural temperature stability. They have a combined control system that can be used individual at the same time and easy to use. We will go for optimal measurement uncertainty for all calibration methods, fit for purpose. So that means that we will not maybe go to the ultra low measurement uncertainty, but something that we can produce on a daily basis. And we like to have low noise level in the laboratories. Realization of the liquid flow calibration facility. And I'll give you a timeline. In December 2020, just before Christmas, I received a call from my managing director telling me that funding was there and that we could start the project. So immediately in the month of January, we made sure that we had a project team established. We then had to still find a location because we had 2 locations left that we needed to pick one for the construction. And it was a long time of designing and engineering. And finally, in March of 2022, the first fall went into the ground so that we could start the construction. Commissioning is due next month. And then in February, we hope that our first customer will get traceability for its flow meter to the new location. The project team that included the LNG facility, because if you remember, the LNG facility also had to move to the European Center for Flow Measurement. The project team was put together with VSL team members. We hired an external project manager and an engineering company. The main contractors for the water flow calibration facilities and building was a main contractor that could do the building. We hired a steel company that can do the piping and support, and an A&E company for the electrical and the control system. The engineering for the water flow facilities was led by VSL. Finding a new location started well before funding was realized. Together with the Port of Rotterdam, 3 of the 5 locations were identified not to be suitable already. If you remember from a previous slide, I talked about the Portos project. The LNG calibration facility already had to move for that project. So together with the Port of Rotterdam, we are already looking for a new location. We asked the Port of Rotterdam if it was possible to include a water flow calibration facility on that location, and they said yes to us. From that moment forward, we had to look into those 2 new locations if they were suitable for the calibration facilities. So we started a short study which location was the best, or if there maybe was a location that did not fit or both did not fit. 2 important studies were included, and one was for vibrations in the field, and also if there were electromagnetic fields on the location. We hired a specialized company that could do the measurements. They could also advise the project team on how to construct a building to take care if there was some vibration or electromagnetic fields. On the other hand, VSL also contacted the manufacturers of weighing scales to ask about the maximum allowed vibrations for the sensitive scales. No clear answer was given, so the current location in Dordrecht was included into the study. On this slide, you see the results of the vibration testing during 1 week at both locations. On the left, the Walrusweg, on the right, the Magellanenstraat. On the Magellanenstraat, you see that there were low frequency vibrations, 2 to 4 Hz. This was caused by slow driving trains. And this can cause a problem if you want to eliminate these vibrations in the construction of the building. The higher the frequency, the easier it is to eliminate those vibrations. At least that is what the company that was specialized told us. The background noise was larger on both locations in relationship to Dordrecht, but less peaks were observed. Based on the low frequency at the Magellanenstraat, the Walrusweg was selected to be fitted, and we needed to do more investigation if that was the location we wanted to put the new calibration facility on. The EM field study did not cause a red flag. After all studies were done, the Walrusweg was selected. And if you want to see that into relationship of the old facilities, you can see that here in this map from the Port of Rotterdam. These are the 2 locations where we used to be calibrating. The bottom one is in the city of Dordrecht, where we have the water flow and volume laboratories. And on the left, you can see the LNG calibration facility. The new location is somewhere in the middle, more closer to the LNG calibration facility, and about 30 minutes from the city of Rotterdam. In relationship to the city of Delft, where our main office is, you can see that here in the circle. This is a satellite view from the new location, where you can see in the drawing where the new water flow building will be and the LNG calibration facility. It is located at the Walrusweg 5 in the Maasvlakte, Rotterdam, with port number 7006 in the Netherlands. Now I'm going to talk a little bit about the design and the engineering. So one part was the civil design and engineering team that worked on the building and the grounds, taking care of at least the following things. The wishes of VSL, the building needed to be fitted around the flow calibration facility. So if you remember, the Dordrecht facilities were put into the building. Here the building had to match the calibration facility. It was all about metrology. Of course, we had to take in account the advice from the studies about the vibrations, etc. The building and environmental permit issued by the local government agency, of course, we need to take care of that too. and Dutch and European law. And there were much more things we had to think about. And in the pictures, you see a 3D model on the right, the picture that I use more in this presentation. And in the other pictures, you can see a little bit the building from the drawings. Now the fun engineering that was led by myself for the piping, electrics, instruments, standard and control system. We of course had to take care of metrology, always first and above everything. You had to think about stability of the flow, temperature and pressure, correct sizing of the system, selection of the measurement standards and instrumentation, selection of equipment and control system, location of the system, work with civil team to avoid clashes between the designs, software and many other things. And you see a few drawings here. You see, for example, the master meter sections of the WF2500 here in the bottom. You see the instrument panel where we can put all the connections of customer flow meters into the control system. That's on the right top. And then of course you see a little bit of the process instruments diagram. So here you can see everything together. The civil construction and the engineering done on the piping. So what are we looking at here? We are looking at the Waterflow 2500 system. This is the one that you see here in the front. So the pumps are below here in the pump room. The storage tank is below it. So we pump up through this green section that you can see here, which are the master meters, the Coriolis master meters. Now we pump it through this section where we can build in a customer flow meter, and then we have the control system to return to the water storage. A cross pipe connection is made to the 650 system to go to the gravimetric system. The 650 system has also a pump in the same pump room. It pumps here through this blue line here into the first master meter section for the larger flow rates. Then it goes into the meter under test section for a customer meter for the more larger meters of that system. And on the back we have the compact prover, and we have 4 weighing scales standing here. The largest one you can see here, that's a 10-ton weighing scale. Next to the larger customer on the test section, we have a smaller one that you cannot see very clearly in this picture, but it's here. That's for the smaller meters, where we also have a Coriolis master meter section as master meters for calibrating flow meters. In this picture, you also see a weighing scale, a 3.5-ton weighing scale in the basement, where we can calibrate flow meters with, but also do volumetric instruments, so test measures. We can put even a truck on the outside of this building and flow into this 3.5-ton weighing scale. On the right, you see the volume lab that's located here, and that has a storage tank of 10,000 liters on top of it, also for volumetric calibrations. In the next couple of slides, I will talk about the construction, and I'm only using pictures for that, as I think that will give you a very nice way of looking at what we are doing. On the picture, I'm putting my laser pointer towards, you can see the poles driven into the ground. Why do we put poles into the ground? Is that in the Netherlands, we have soft ground, so we need to find a good formation of sand where we can put the building on top of. Once that is being put in the ground, we move to the pictures, the 2 pictures that I'm now trying to highlight for you, where we are making the basement, so the cellars. And the cellars, of course, is the water bunker, the pump room, and the basement where we have the weighing scale of the 3.5-ton scale in that you saw before. So here you see that they are preparing to pour the concrete Here you can see that the concrete is already there. And on the next picture here, you can see that the floor is being poured on top of that and ready for the construction that you can see right here on this picture. On the top left, you can see the moment where we put in the first pole. That's a very important moment always in the Netherlands. So the whole project team and the team that will operate the facility were there at the time. So next I'm showing you parts of the steel construction for the water flow calibration facilities. Here you can see that we, before the concrete was poured in, we already made sure that some of the connections from the water bunker to the pumps, to the pump room, were already put in there, so that we had a very tight, leak-tight connection between the two locations. On this picture, you can see that same flange coming out, DN 400 in this case, going towards the pump. And you can see here they are the weldings is not completely done yet because we needed to exactly line out the pump. On this picture, you can see the largest pump. Two of these we have going in the hole with a specialized crane, and it was better to do it before the wall was put into the building so that we had easy access to move it in. On the other pictures, you see the construction of the master meter section here at the construction company, and then later on placed in the new laboratory. And you can see already here the walls are up, the roof is there, and the overhead crane is at that moment working. This is a few days later when we put in the first master meters. Then some other pictures. Here you can see the outside being realized. This is how it looked like last week. Some other pictures of some valve, the biggest valve that we have being put in. Here you can see the electronics we will work with, the control system at the manufacturer. That's also making the software. At least part of the software will be made by them. And here we are visiting them just to check out if things are going well. You can see the outside connections because we can also calibrate meters on small trucks if that's needed. Of course, you have seen the construction of the master meter section, and to make sure that a ultrasonic or turbine meter from a customer has a nice, correct flow profile, we use these conditioning plates. Here's some other pictures of concrete being poured into the building, and here's some control valves on the WF2500 system. What I showed you was mostly the water flow 2500 and the building. You would think, why is the 650 water flow 650 not here yet? That is because we are still operating the facility in Dordrecht until the end of this year. So we have a few steps to go. So here I listed them a little bit for you. We actually put water into the facility yesterday and today. On November 30th, the building will be ready, and we will start commissioning the day later with the water flow 2500. On the 5th of December, we will start up the pumps for the first time. It's our two large pumps. In December the 16th, our last customer calibration will take place in Dordrecht. Then in January 9th, we will start moving the equipment from Dordrecht for the water flow 650. And in March of next year, the water flow 650 will be ready for commissioning. And on March 28th, we have the opening event with customers and relations. And in April or May, I am expecting that we will have the audit for our accreditation. Now I'll briefly talk about the transfer of the standards from Dordrecht to the Maasvlakte. That means that we need measurement traceability from Dordrecht to the Maasvlakte. Of course, I do not have a lot of results yet. You have already some tests done in Dordrecht, but I will talk about this during the opening event in March, and I will present that to show you that the results in Dordrecht are equal to the ones at the Maasvlakte, or close to it, within the uncertainty boundaries. Good to know is that all standards and instruments are calibrated before sent to the new facility. So that means they come in with a calibration, even though we can calibrate a lot of them on location. Links are made to ensure the same results can be provided as in Dordrecht. How do we do that? We also asked the manufacturers to calibrate the instruments, and we also made a link, for example, with the largest Coriolis meters to our colleagues in Germany of PTB. So that means we have a triangular, or maybe even more, so that if we leave the Dordrecht office and we cannot calibrate that anymore, we still have a link because we already know the differences between PTB and the manufacturer and our old facility. Then we go to the new facility. If something would be wrong, we already know it up front of that. And what we will do is that the facilities will be operating under the CIPM MRA, and the CIPM, you do not recognize arrangement, is the framework through which national metrology institutes demonstrate the international equivalence of their measurement standards. The calibration and measurement certificates they issue. And that means that we will do comparisons once we are in operations with our colleagues around the world to make sure that our results are equal to theirs. Next to that, of course, we will obtain an ISO 17025 accreditation as soon as possible. A moving plan has already been sent to the accreditation body RVA that does that in the Netherlands. So what are the new measurement capabilities and what can VSL do for you with these new facilities? So I said we have two facilities, so that means we can calibrate on two facilities at the same time. It's water at ambient conditions. We can keep the temperature stable because of our bunker with the natural cooling coming from the ground. The minimum flow rate 0.03 cubic meter per hour up to 2500 cubic meter per hour. But please note that of course we have to commission the facilities, and that means that we are not 100% sure that this will be the flow rates. We have three calibration methods in the facilities: gravimetric, a prover, and master meter method. The CMCs, and of course we still have to claim them and have to prove that we can do that, they will be equal to the ones in Dordrecht from 0.02% to 0.05%. The pipe sizes that we can calibrate are from 300 to 3 millimeters, so that means 12 inch to 1/8 inch. On request we can go larger. What kind of type of flow meters can we calibrate? Coriolis mass flow meters, ultrasonic, turbine, positive displacement, electromagnetic, delta P's, and other meters. I don't think we have a limitation there. The signals that we can handle are pulse, milliamps, and other on request. The flange connection on request, we can supply the available connections. And if we do not have the connection, we will work with you to get a connection. And the accreditations, of course, like I already told you in the previous slide, CIPM MRA and ISO 17025. Once the construction and the commissioning is done for all the facilities, the European Center for Flow Measurement can do a lot of calibrations for you. First of all, the liquid volume laboratory, where we can do test measures, all kinds of volume instruments from small to big. We have the liquid flow meter calibration facilities, the W650 and the WF2500 system. And we can do LNG calibrations, but also liquid nitrogen calibrations for you, and also test sampling systems for LNG. If you want to follow us, you can do that on LinkedIn using the link that is showing below. And of course, you're welcome to visit us, and especially during our European Flow Measurement workshop. So yeah, do visit us during the European Flow Measurement workshop that we will do for the 7th time already. And the theme this time is the measurement challenges in the energy transition. The dates are next year in March 28th, 29th and 30th. So the European Flow Measurement Workshop has a high ambition to exchange knowledge about the measurement and to establish strengthened relationships to support and/or accelerate developments in measurement. The first 2 days will be at a pop-up event location at the Maasvlakte, so that will be at the new location, and the last day will be in our headquarters in Delft. So the content of the workshop will be lectures about the flow measurement challenges in the energy transition. Of course, we will have the grand opening of the new European Centre for Flow Measurement. You will have a guided tour, unique insight into the European Centre for Flow Measurement, the new tests of facilities that we have there. So it's a water flow laboratory, the control room, the pump room, the volume laboratory, the LNG facility, and we will also bring the Higgs. And the Higgs is the hydrogen facility that we can use for the filling stations for cars. It's a matrix workshop where companies bring their potential measurement solutions to your attention. There's also a nice networking dinner, including a boat tour through the port of Rotterdam. And for more information about the event, visit VSL.nl EMF-MWS. This concludes the recording of the webinar of November 9, 2022 about the new liquid flow meter calibration facilities at the European Centre for Flow Measurement. If you have questions about this presentation, send them to one of the email addresses listed on the left. So that can be info@vsl.nl, fsmits@vsl.nl, jboonman@vsl.nl. I thank you for your attention and see you next time.